we can get started. Everybody's full. Okay, so this talk is about ATS and Kubernetes. So the beginning of it is probably just some background information, and let's just see a show of hand. Anybody really comfortable with Kubernetes? And then I can just see how much I can go deep or how much I should go with a lot of information. So, all right. So you know a lot about Kubernetes, right? Or you know your way around. Yeah. Yeah. All right. Cool. So before we do any of the things, so this is actually just some background information so you can understand where we come from. So so I work for the Verizon Media. So here is like a 10,000 levels deep highs architecture, right? So all the requests coming in, we have a CDN, and then so Alan is actually working with the group that is managing the CDN, which is at the edge top and handling the proxying of the request. It then goes into the data center. So I'm responsible for the architectural layer here, which is called the media ATS, that is intercepting the request and then forward it to the origins for that. So keep this in mind. So this actually will come in handy and see why we make certain decisions that is very unlike how CDN works, right? So if you break down our media ATS, so we have multiple clusters. So for example, Yahoo front page will have its own cluster, and then AOL will have its own cluster, and then sports and finance.yahoo.com have their own cluster. So what's a cluster? Right? The cluster is actually a router ATS and an optional caching ATS. So the router ATS get the request, and then they do the hierarchical caching using the parent.config, and then fan off to multiple different ATS for for caching purpose before it goes to the origin for that. So this is like a really high level how this works, right? Other things related to our architecture is we never use raw disk for cache storage. So we basically have the box with a lot of memory, and then we carve out some memory as the RAM disk and then use it as a cache storage. Hierarchical caching is in use. So other thing is in front of the router ATS, we have the hardware with load balance across the multiple multiple router ATS that we have for that. So that's the basic idea. So so the beginning, right? So we want to do Kubernetes. It's not just for ATS, it's actually for the whole organization. So the whole organization actually in this case moved faster than us. So we have our project name is kind of funny. We call it Omega, which is the end of everything, but whatever. So this is the beginning. So for a little bit of introduction of what Kubernetes is, right? You can see the color of the boxes, and you can kind of see what's going on. So I'm going to go with the open source Kubernetes first. So in the Kubernetes world, we have something called a node. So the node basically represent a bare metal machines, or sometimes people will use OpenStack VM for that. So basically, these are raw computing power that you can manage, and now you want to manage it. So inside the node, we have pods. Pods is a collection of containers, okay? And so we can have multiple pods within the node. So how do I judge what do I put into the pod, right? You put your whole application into the pod. So for example, in ATS world, right, we have the ATS, and we should put it into one container. And then you have other daemons that you run. For example, there's a daemon to actually collect the logs and send it somewhere. There's daemons to do other things, for example. So that's part of your whole application. And you group them into one pod. And then you will separate each of the important process that you have in separate containers for that. So now what it does give you is it gives you some way to actually utilize containers to containerize your application. So in a really powerful box, you can have multiple instances of your application running at the same time for that. So all these are controlled by some Kubernetes open source entity called a Kubernetes that would actually know how to manage all these things. So backend, so there's a lot of control API that I'm not going to talk too much about, but it does allow you to do some authentication and authorization. So this is the CLI command that is interacting with the whole system. So you can instruct to say that, oh, I want 5 instances of my PHP application to be up and running. And they will be up and running with their companion processes, such as those that's getting the logs. And
do I want to run multiple pods of the same application?
say that again. What do you want to what?
Why would we have multiple pods?
Because we want to actually be able to run more than one instances of the applications on multiple boxes. Some of the boxes has higher computing power. Some of them don't. So you can actually be able to quantify how much computing power you have by having a virtual CPU type of concept. And so you have a smaller box, then it will have like 2 virtual CPU. And then you have a bigger box, then you have like 4 virtual CPUs. So now you can say, I run one instance of application for one virtual CPU. And so now you will be able to actually better judge how many instances you actually want to run, and then depending on your requirement in terms of your traffics for them.
So the pod contains multiple servers?
The pods contain just one applications of your for yourself. Like, so if it is a Java application, then the pod will have one container for the Java application, one container for, let's say, the Spunk daemon, and then one container for like a cron job that is doing something.
Okay, and then you have multiple pods.
And then you can have multiple pods in the same.
So a pod is a server.
A pod is a group of containers.
Okay.
It's not necessarily a one server. Yeah. You can have multiple server software running. It depends on how your application really works in the real world. So you can have like, something like that. So that's the basic idea of how you group your node, your pod, and your container. And Kubernetes is a way to actually manage all your hardware for you. And then, like, you have your all your application containerized, and then you have multiple different Docker images for your containers and in some repository. And it is able to actually, based on your command, and be able to schedule the applications to say, oh, I want 5 instances of my PHP apps and running, and they will be picking the node that can support you and be able to put your application into those nodes. So it is like really like a container orchestration, scheduling utility for you to manage your physical computing power for them. Yeah. Cool. Right. So what do we do, right? So we want to do it for Yahoo, right? So in the Yahoo media, which is we contain a lot of properties. We have homepage, we have sports, we have finance, we have news, etc. So there is multiple different APIs that is for each of those applications. So altogether, we have hundreds and different APIs and applications that is running. So one of the things that we really want to try this is because if you guys have been working with Yahoo, you will know that once a year we have this problem with NFL football, and then we know that the NFL season is going to demand a lot of attention, and we kind of repurpose all our hardware and to actually move it so that it can be able to serve the sports traffic for that. And this yearly maneuver is actually causing a lot of troubles every year for that. So we think that this is actually going to help us. And then I'm actually going to go through a little bit of other benefits that we get as well too. But back to this. So this is our phase 1 architecture actually. So once you have all your application up there, right, you need a routing. So that's why we have this thing called the Omega Ingress here. So the Omega Ingress is going to actually get the instruction from Kubernetes and know that how many different applications has been deployed. And it will be able to do the correct routing for that. So for example, if it is a sports API, they know that the port for the sports API is actually just put into these 2 nodes. So So then it will know that, okay, I need to load balance across these two pods for my sports API traffic for that. So we'll go into what's the Omega ingress is later on. And then on top of that, we have our ATS layer. So which is our ATS layer, trying to accept the traffic from the outside world and then actually pass it on to the Omega ingress, which is it itself is an ATS. And then it will do the routing into the correct pod for the particular API that we want to call.
Why have two ATS?
That's a bad thing. So we'll talk about in the phase one at the end, we will be eliminating that. But it is it's kind of like an organizational problem. So one team do this, one team do that. So it's better to actually let them have two layers and then later on combine the teams together so as to try to eliminate that layer. But it is a bad thing right now.
Why not have Kubernetes do the routing or what's special about it?
Because we are not, in the phase one, we are not doing the ATS layer. So all of these are just all our Java, PHP, and Node.js.
You can create the Kubernetes deployments and it'll route to those things and do all that stuff for you.
Exactly. So you can, but we kind of start like with a small phase one. So you'll see in phase two and phase three, then we'll go into the ATS. So in this world, we are just talking about all the teams that is doing applications. They have the Java, Node.js, and PHP application, and they all put this into containers and let the Kubernetes to manage all the deployment for that. Yeah. Cool. And then
If you're running ATS, then you're Ingress Controller?
no, you're good. Yeah, but we will touch into what Ingress Controller is. And then at this point, I can give you a preview. This is not an Ingress Controller, but it looks very close to an Ingress Controller. And it's almost just like that. But then it is not right now. So it's also like some of the things that when we adopt this like a year or two ago, we weren't very sure how to actually approach that. So we didn't write exactly a Ingress Controller for that. Okay, so that's this one. So Omega, right? So we build like a lightweight set of tools and templates that try to make it easier for us to do deploy the Kubernetes workload into our infrastructure, right? Because a lot of things can be abstracted out. So for example, we have only a common set of container that you can base on. So people who build PHP apps or people who build Java apps, they have a base container that they can build on top of that. And so we try to provide that out of this. There's common needs for monitoring, authentication and authorization. In Yahoo, we have one single authentication and authorizations infrastructure. So we need to have the Kubernetes to actually be leveraging that in order to say, oh, okay, this team can actually do deployment into this namespace, while the other team can only do deployment into that namespace. And this namespace has a certain quota. They have only like 10,000 virtual CPU they can do. And the other one is a small team, so they can only have 200 virtual CPU they can use. So all these authorizations, we don't want the team to actually deal with it. So the Omega project is trying to make this to be a little bit more abstract this out for that. And so it's basically just an augmentation to that. It's not like we are replacing the Kubernetes for that. It's just adding more tools and giving some conventions and templates on top of the Kubernetes. So what's the Omega ingress? So Omega ingress is actually an ATS server. So the ATS server runs a plugin that we have an open source. And then I'll talk about what this plugin does, right? But on top of that, what happened is we have some kind of a daemon running, which we call the TMGR agent. The TMGR agent will actually talk to the Kubernetes API, and we know that how many applications are deployed, and what are the domains that they want them to be. And so we generated two files, right? So we know the list of the domains that we have to support in this ATS, and we know all the different endpoints, which is how many different pods we want to have for certain domains for that. And then it goes through another daemon or other job, which we call the TMGR status. So this is actually going to do health check, because even though your pod is up, it might not be able to serve traffic. So there might be crashes, or there might be some bad deployments and things like that. So not all pods can serve traffic. So if you say you deploy on like a 10,000 pod, so some of them may fail or something like that. So there's some way to actually be for us to do health checks so that we make sure those pods are running before we come up with a list of the real pods that we can route to for a specific domain. So all those information are compiled into like a binary format and then feed it into the plugin. So what the plugin does is when a request comes in for say sports API or finance API and then try to give you a request for that, then it will know what are the pods that is up and running and route to those pods for that. And so if you know what an Ingress Controller is, that's kind of almost just like an Ingress Controller. But we didn't do that yet. So this is like kind of like 1 or 2 years ago when we first come up with that. So this is the things, right? So in some way, we were actually trying to use the load balancer plugin, which Miles was talking about, but it's too slow for doing updates. Why, right? Because the load balancer plugin takes like a configuration of like how many machines you have that you want to load balance across for a domain, right? But every time you make the change, you have to call traffic CTL config reload. And we find that this is way too slow for that. So all of this update doesn't require traffic CTL config reload. It's all just doing some watch over some files. If it get update, I only update certain hash table in memory in order to actually do the make the routing changes accordingly for that. And we have to do it really, really fast because we have hundreds of teams that is having different domains and endpoint setups, right? And every minute, like some really unstable apps that have their pods go down very easily. So the frequency of this getting updates is enormous. So we cannot do traffic CTL config reload every 10 seconds, for example, right? So that's why this is actually very important for us to have a plugin that actually watch over some file changes and be able to react like right away for that. All right. So this is the result. We finished our phase 1. So this is the result. And majority of our whole media workloads is migrated to Kubernetes. And we actually have a lot of saving on the machines because of the fact that at the beginning I talked about sports being a really huge properties and a pain in the ass for a lot of people when it comes time for the NFL season and then grab everybody's machines, right? So you can see like as an organization how bad it is that it will actually force you to think about your hardware utilization, right? Your finance team, you will say, okay, I want to get I'm going to serve a certain amount of traffic. So I need 30 machines, right? But because of the fact that I know that I might get some spike, I know that sports might take my machines or something like that, I would over-procure and I'll get 100 machines instead. So now you have how many teams? You have 10 teams later. Then you will see how much more hardware that you are procuring than you actually necessarily need. Right? But if we take this away from all the teams and we get this everybody to actually get the computing power from a single pool of resources, then they would be actually sharing this pool. And they won't be over-procuring as much because they know that if they have the needs, then the system can actually be putting more pods to their use almost instantaneously. You don't have to wait, right? One of the really cool findings we find is sports and finance actually works very well together because when people are actually watching a sports event, there's seldom any heavy trading actually going on for that. So that's kind of another thing that we figured out that it fits nicely to our end-to-end and year-round major events for major media companies for that. Other things is, of course, you have less number of machines, but you serve the same amount of traffic, and so your utilization is high. So your CPU utilization is like 2 or 3 times higher than before as well too. Another thing that really help us is in terms of deployment and management. right? Before every single team has to find out their own, have to come up with their own deployment and management system. They might have a slightly different script to push things and stuff like that. Now, everybody's just use Kubernetes. Everybody interact with the same machines to actually say, oh, okay, I have a container, and then I'm pushing this container out, and the container can get scaled up in pretty much the same way for that. So this is pretty cool. So we finished our phase 1, and as some of you guys notice, there's a lot of redundancy here. So the first thing we realize is that the Omega Ingress is actually redundant. So if the ATS v2, if the ATS machine on top of it can do the load balancing, you actually don't need that. So we are actually in the middle of a post phase 1 optimizations at the moment for that. All right. So phase 2, right? So we get everybody to use Kubernetes now. Now is the time for the ATS team, which is my team, to actually start using Kubernetes. So as I said before, we have mostly 2 types of workload, right? We have the router workload, and then we have the caching workload. So we start with the caching workload first. So it's easy to actually do the caching workload, right? So we just start with a base image. We have our own internal RHEL image, and then we put the ATS on, we put the plugins on, and we put our tools and script on, so then we come up with our base image. And so for each of the cluster, they have their own caching ATS layer. So that would be their extended image. So they will have their own configuration files. So they might run a different set of plugins in real time, at runtime, or their storage requirement can be different between front page and AOL, for example. And of course, their mapping rules may be also slightly different as well. So each of them has a slightly different configurations from each other. So we have a base image, we have an extended image. And so all this image, of course, is in the private repo, so you wouldn't be finding it out on the internet. Say that again? Oh, no, the certificate is actually procured at runtime. So there's a, so there's some, so you can see the new service and existing service. So in Yahoo, we have existing service, that is our authorities in authentication and authorization. We build a hook to it so that it can hook into the Kubernetes. So basically, we let the Kubernetes to know all these things, and when the pod is up and running, they will know that, oh, I'm in a role for sports.yahoo.com versus I'm in a role for finance.yahoo.com. Then they will fetch different certificates accordingly for that. Yeah. Fine. So when we actually run the container, some of the things happens, and the entry point for the Docker file is that, as I said, we actually use the RAM disk a lot. So it will actually create RAM disk as part of the startup of the Docker image, and then we created some liveness and readiness probes endpoints, and we start the server. So what's a liveness and readiness? So in the Kubernetes, there's things called liveness versus readiness. Let me see if I'm correct. Liveness means that you can treat these two as a health check, but they have various different meanings for the health check. So liveness is whether the Kubernetes determine you are healthy or not, and whether they will restart you or not. And readiness is whether you're ready to serve traffic or not. So you can be alive, but you don't want them to serve traffic because they're experimental, and I don't want them to be as part of the serving fleet yet. I can just turn off the readiness probe and for that, right? But the liveness probe is almost always to tied to the fact that whether your server is healthy or not. And so if your server is not healthy, you've got to make sure that the liveness probe is actually failing, so that Kubernetes will know that, oh, okay, you are not healthy. I'd rather just kill you off and then start you off somewhere in a different pod, in a different node, and put the pod in that for that. So we are in the middle of that a little bit of the things is we go with a lot of cautions here. So one way of doing deployment in Kubernetes is we can do it in a way of what we call the dedicated nodes and a host network. So what it means is I can mark a node as can have only one pod. So in our actual use case, we are not actually serving two caching ATS on the same node at this point. So we are still actually just putting one ATS on one physical bare metal box at the beginning. But when we stabilize, we would want to be actually making it a little bit better so that we can actually take advantage of what Kubernetes allows us to do, which is to put multiple pods in the same physical node, and then for that, yeah. So we have Splunk and other monitoring processes. So they are what we call the sidecars. So these are the containers that is also that get installed together with the pod. So as I said, the pod has multiple containers. So one container will have the ATS, another container will have the Splunk daemon, and then another container will have our other monitoring daemon for that. And so it's like a buffet. You go in and you pick to say which of the functionality you want. You put them all into one single pod, and then you get deployed for that. Jan was questioning this, so but we have integration with authentication and authorization system, so that we know whether you are allowed to create pods in a specific namespace or not, and how many pods you are allowed to create. So all these are predetermined when you sign up to actually be on our framework for that. So all these are heavily controlled, and this will allow you to actually attach your certificate to a specific group, so that when you set your specific application is up and running, then the certificate will be putting into the pod, so that when it's up and running, it will be able to use it right away. We run into a few problems, and then Susan actually helped us to fix it. So this is one of the PR about the privilege acquisition. So we changed the privilege acquisitions in ATS before. That is different from before. So let me see.
Oh, that, right.
So what did we do is we said we need three things. We need the netadmin, the bind service, and the IPC lock, right? But we actually don't need all three to run in our specific case. All we really need is the bind service. Yeah. So then she changed it so that right now, if we can't get all three, before her fix, if we cannot get all three, the things will fail. So ATS will not start. But now they will actually allow us to say that, oh, if I don't get all three, I'm fine. So I just grab whatever I can first, and then when the application is actually up and running, they will fail for that if I don't actually have the capability for this. So to change it in such a way for that. So why, right? Because of security issue. Right. So if you're running Docker, like on your own machines or things like that, a lot of the time you just run your Docker images or instances in privilege mode, meaning you can do anything. But that's a bad thing in terms of security practice. So instead, the way that we allow people to run the Docker images is to say that I only give you the capability that you're supposed to have, and we don't give you everything. So our framework, when we do our deployment of our Kubernetes in this way, we just limit the capabilities of just allowing to do like bind services for the particular namespace for ATS, for example. And so then all our ATS deployment fails, because without this PR fix, the ATS will not start at all, because the Docker instances doesn't have the capabilities that it needs for that. So that's one reason that we actually work with Susan to get this fixed. All right. So now our caching ATS is all good, right? Now, before we can claim victory in our phase 2, one other thing is our router ATS needs to recognize that our caching ATS is now in Kubernetes. So the router ATS also needs to actually, even though the router ATS is not in pods or in Docker images and things like that, right? It still needs to talk to Kubernetes to know how many caching ATS I have to talk to. And then we dynamically update our parent.config based on that. So we write a lot of script to actually make it as in pretty much the same way as you see here, but turn this into a kind of like a script in which we would be talking to the Kubernetes to find out the list of the domain that we want to serve and the list of the pods that we have. And then we do health check against all those pods in order to come up with the final list of the pods that we want to route to for that. So all these are there in order to allow us to be able to generate the parent.config dynamically. So this is actually less than ideal because if you're updating the parent.config, the only way for it to actually getting the changes is to do traffic CTL config reload. So this is actually a part for us that we don't know how to overcome yet, but we are trying to find some solutions for that. Is to, can I update the list of my parents dynamically without running the traffic CTL config reload? So we are looking at some of the changes you guys are trying to make in terms of API and things like that. But at this point, we are still relying on traffic CTL config reload to uptake the changes that was being done on the parent.config. Yeah, cool. Yeah, the way that we figure out is there's some impact every time when you run config reload. So it will kind of slow down a little bit. It sometimes affects the live traffic here and there. It all depends on how many plugins you're running and how much traffic you're actually taking. And your experience will vary. But for us, it is relatively okay because of this. Because we are deploying in dedicated nodes as our first step. And so one node has only one pod, and we seldom have the way to scale it up for caching ATS. So it's relatively tame by having this kind of a setup at this point.
So you want like an API
to set the parents dynamically without restarting ATS. Yeah, without reloading ATS as well. Yes. Yeah, that would be fine too. Yeah.
Wait, do you understand why traffic would slow down? Why traffic? Yeah,
if you have the plugins or remaps, a lot of the rules.
That's supposed to happen when it's on track. That's true. But should happen on a task. So what does slow mean? It takes a long time.
Yes. So let's say we have 10 machines. We have 10 pods, right? And then we change it to 20 pods, right? We find that it would take somewhere between a few seconds to a couple minutes for it to getting the changes, yeah, to be effective. Yeah. Say it again.
It affects traffic performance as a
No, it affects how long it takes for these changes to happen.
Okay, so that's understandable. If you have a 25,000 line, you have to right, it could take a filter chip before it's full.
Right, but
that doesn't mean that ATS is slow when it's.
No, ATS is not.
It's slow.
It's not slow. Yeah, it's slow to take effect. Yeah, I should say that. Yeah. Yes, because like the reason why we scale up is because we are under like some stress in terms of traffic, right? So then we was not able to actually alleviate like high traffic problem like in in a timely manner. We will have to like wait for a while for it to be like completely sure that the new pods are up and running. Yeah.
Is this a side effect of the fact that you offer power on the...
Yes. Yes, it's kind of the same thing. So I'm saying about the same thing. It takes like unpredictable amount of time for the changes to be effective. Yeah.
Well, what's the expectation?
The expectation would be like much faster.
You
Yeah.
know the configs in 0 time always, regardless of the complexity. But you only want to update the parent config, right?
Yeah, I only want to update the parent config.
And
Yeah.
you've taken the penalty of reloading the VNAS.
Yes. Yeah.
ATS will only reload the configuration files that
So
bugs in that will do this. He may be hitting the button.
yeah.
Because he's running 7.2 with.
So there's a so in the newer versions we don't have this problem. You're saying?
we depend on this. I mean, we require it, but we definitely
Okay.
depend on this behavior. Like we touch files and something to be reloaded.
Okay.
They're not touched, they're not.
Cool.
SSL only start kind of gets wonky, but I think that.
But I think the thing is, you may definitely get back forward to the 7.1 track, but not ours. Now, we did 7.2. Unless you give a room, I asked your long-term director. I did it 7.2 or just, you know.
I mean, considering I've been working on ATS and Kubernetes for the last year, that would
All right.
and just as curious,
Yep. Yeah. I'll take a look at the latest and see.
The way to check that would be when you're the log that you have is like what's happening. It would say not done, not config done reloading, and inherent config done reloading. Right? You shouldn't see things like those other files being talked about.
Yeah.
When you go and punch them.
Right now, I think the way is like we have to touch the remap.config for it to happen because of the version we are in, 7.12 or something. Yeah.
and that's been fixed too. The sub files, the sub,
That does one. That sounds very familiar.
yeah, I fixed that within the last year.
Okay.
But the sub config, remap config,
Uh-huh.
should be percolated back up to.
Right here.
Alan, you're going to backpot this for me?
It was.
Oh, you gotta go to A.
This one was K. It says make sure traffic control config reload only reloads config doesn't change.
Hey, what do you mean?
Which that was August of 2018.
Do we have this in Yahoo already?
No,
Oh,
I don't think. Well, maybe. I don't know. It's not. I don't know.
okay. All right. So, Alan, we'll need this. Okay. All right. Cool. All right. So we are like in the middle of phase 1 and phase 2. So all these are like what we are doing. Eventually, we want to be everything in Kubernetes. And so within the data center, everybody will use the same way of actually managing the computing power, doing deployment with much the same way, operate their properties in pretty much the same way, or scale up and down, exactly, etc. Right? So what are some of the challenges that we think at this point we gather enough experience, and then these are the next set of challenges we think we would come into when we try to deal with the last mile of our projects in the next 6 to 18 months or something like that. So the first thing we realize is that the Docker containers, we can actually set a CPU, give a CPU set to a Docker container instance when it's up and running. And then so we can control how many computing resources it is using. And so we think that this is actually not being honored by ATS. So ATS is still going to go through the hardware, what's that called, HW log, to figure out like how many processors you have, and would be creating as many threads as instructed by the HW log. So we think there should be a way, there should be an option to actually obey the CPU set in addition to the existing one that we have.
I thought the HW logs have actually
In our test, it's not right now.
So you want to pass in? I mean, I'm not sure.
No, the Docker container, when it runs the Docker image, you pass in the CPU set.
Right.
And then I'm looking at like the auto scale things, like in the.
How would the CPU set pass it to the Docker container, get the traffic server, and show up in the EW line? You pass it to the man at arc, or the travel?
I'm not too sure on that.
Okay.
Yeah, but we look at, for example, we look at Envoy. So Envoy has a project to do exactly that. That they would look at CPU set and be able to scale the number of threads based on that.
Well, we'll look for good for how to do it.
Yeah, we can. Yeah, yeah,
Yeah, Envoy does this stuff very, very, very well.
yeah.
You're saying that HW wants them to do this correctly?
We haven't looked like too deep into that, but
I'm rather confused. Is this something specific to K8? So we already have the auto-scale feature.
yeah, we have the auto scale feature, but we find that the auto scale feature in the world of Docker doesn't obey the yeah.
It doesn't what?
It doesn't obey the CPU set that information you pass to the Docker container when you get created for that.
So you're in the Docker, and you have the CPU set to give you the hardware one, not the Docker one, and therefore ATS gets the one. And we used to go through the C group.
And Kubernetes, when you start the thing, you tell it you get half the CPU, of course
You can have in Docker do things like say, using the C groups stuff, you can say only allow this Docker instance to use the CPUs.
Yeah.
So HW log is not going to help you. You need to use the C groups API to get that information.
We haven't looked into that, but I'm saying that this is one of the challenge that we need to solve.
You know, saying from Docker that we would only, when you say, hey, how many CPUs do I have, that's actually even able to tell you what the hardware is.
But the HW log probably works on a much lower level, right? But it's only one kernel. I think that kernel knows all the CPUs, like perhaps the video, all the CPU or everything.
Yeah, I can run some more experiment, but just out of the gate, we just look at it and basically the number of threads that ATS spawning on our inside our Docker container is like just as the same as when it is on the bare metal machine. Yeah. So there's no way to control it at this point. Yeah. At least in our environment. No. I'm using auto scale. Yeah.
You don't use auto-scale, it's 75.
Yeah, that's how we do it in our production, is to not use auto scale and set it to 5 for it to work for us. But I'm saying that we should be able to like do this automatically.
Because if you can't mix and match your hardware, well, we're also not designing your Docker instantiation. Yeah. You have the same hardware, you have one Docker that's two CPUs and one Docker that's
You would have the same thing as a hack.
Yep. Cool. Yeah. Performance testing is very, very much needed. So far, if you look at like how we have been dealing with, we are only dealing with the caching ATS. So because we have a lot of cache hit on the caching ATS, the performance is like no difference from whether we have a Docker or we are on bare metals, as far as we can see. So, but the performance problem probably will be a little bit different when we are doing a more general, different type of proxying for that. Yeah. Just run this. Yeah. No physical list. The 1 gigabit per second. Yeah. We have the for that. Yeah. Oh, we didn't virtualize the network part for that. So it's still everyone has the. Say that again. Just one. Yeah. One. The box has one. Actually, that's probably not true. I've double checked on that. I think we have a more beefier box on the Kubernetes than on our bare metal. Yes. Yeah. In terms of the network capacity. Yeah. Cool. Okay. Cool. The last point is Ingress Controller. I think Stephen was asking Ingress Controller, right? So what it is and how do you do it, right? So we can go with a Nginx example because we don't have Ingress Controller ourselves. So what's an Ingress Controller? So let's start with a very simple example. And so in this very simple example, you can follow the blog post. It's actually very easy. And if you want to play with Kubernetes right now, it is really, really easy to do it without much fuss. And so in my laptop, I installed the Docker desktop version in my Mac. And actually there's a flag to turn on Kubernetes. So you can, I already enabled, I already broke my own thing, so my demo probably won't work. But you can enable Kubernetes, and so now you will have the whole entire ecosystem on your machines, and you can actually follow this example to actually get this to work right on your Mac, following this example. So this example is very simple. So we have a backend system. That is, there's some Docker container standard image that is rendering a static site. So we are saying that we create 2 parts for that, and then we create another 2 parts. Both of them are under 2 different names. So this is 2 different applications. So in the end, we will have 4 parts that we create out of this. So this is the deployment setup in terms of Kubernetes. And you need to actually provide a service that is going to make your Kubernetes pod up and running. So let me see, is it really that my stuff is done now?
So that question is this configuration standard for all Kubernetes
Yes.
ingresses?
Yes. No, not Ingress. Mm-hmm. No, I'm starting from the beginning, saying that you have like 2 applications. So you set up the application and up and running. Now, how do you use Nginx to actually route the traffic to that? And so, let's see. Yeah, so if I run the 2 files that you were just shown, I'm actually creating 4 parts. And then I have 2 services that I created for that. So then inside of Kubernetes, this application is up and running. So now the next thing is I want to use Nginx to route the traffic into these 2 applications, right? So basically I want to say /app1, then go to this first app. /app2, go to the second app for that. So to actually get it to work, we can have a namespace that I create first. The reason that you create a namespace, you can actually wipe out the whole namespace, so your whole stuff can actually go away very easily, and you can recreate it in a slightly different namespace name under different names if you want to, and for example. So this is one way to easily clean up all your stuff very quickly. So we'll create the Nginx under the namespace of Ingress. The first thing is Nginx needs a really stupid backend machines to serve some health check. So we actually create a fake backend using some given images, and we started with 2 replica. And so then I will have 2 pods that is serving a specific endpoint that will serve the health check that I need for the Nginx. So once I run this, so I have the deployment here, and then I have the services. And so if I look at my Ingress, then you'll see I have 2 default backend, that is the pod, and then I have 1 service for that. So now I have, the next thing I'll create is this is a little concept called a config map. So a config map is your configurations. So you have a name value pair that you want. For example, in Nginx world, there's this thing called the ATS status. I want to set it to true. Now you can actually create a config map, and it will be a name value pair that is actually being recorded inside Nginx, and so inside Kubernetes. So when the Nginx application is up and running, it can actually pick up this config map and then make configuration changes according to what you want when it is up and running for that. So once you have a config map, the other things that we actually started to create is the actual container containing the Nginx. So this is actually, we have to use a specific image, which is containing the Nginx as Ingress Controller. So what does that actually mean? There's a mouthful on this. So basically, it's a Docker container having two things. It has the Nginx as the server. It also has a daemon to actually talk to the Kubernetes to find out your configuration changes, to find out your routing changes, and then it will apply that to the Nginx and actually reload it. So all these are done by the daemon process that is running inside the Docker container that is containing the Nginx as well. So when we define the fact that we want to have these things, we will be reusing what we just defined, which is we have a config map. So I don't just want Nginx to run. I also want it to run with the configuration changes I want it to have. So I can have multiple different configurations, settings for one application that I want, or I can have a set of a different type of settings for a different application I want, and I can actually deploy Nginx with configuration set A or configuration set B in whichever way I want for that too. And so once I created this, that's not enough. Well, we need to give the new namespace access to the Kubernetes API. So this is actually creating the roles and the necessary authentication, allowing the Ingress namespace to actually talk to the Kubernetes API. So then, when your Nginx Ingress Controller image is running, it can actually talk to the Kubernetes API to find out the changes in routing rules, etc. for that. So once you create all this stuff, and now it comes the interesting part. So this is a native object of what they call Ingress. So now I can say that I have created an Ingress group, and then I'm saying this as the fact that a specific incoming request for a specific host name can be using my services. And then I want it to happen in this way. And I capture this information as my Ingress object. And so this Ingress object has no implication at all if you have no Nginx object up and running. And so this is actually routing the health check to the default backend that I was actually mentioning. While I create, in this example, I create another Ingress object that is actually routing the things I was talking about just now. I want /app_a to go to the first app, that is the two part I created. I want /app_b to go to the second application that is with the two parts that I created. So now I have all this Ingress, and then I have the Ingress controller, the Nginx Ingress controller up and running. When I actually create the service for that, and I would be hooking up to them, saying that I'm now wanting my port 30,000 to actually go to to be going to the Nginx Ingress controller that I have. And it will pick up the Ingress object that I just defined. And all this will be actually tied together in such a way. And then the 30,000 port will actually go to the the health checks that I'm actually exposing in the above examples for that. So all this actually tie together the whole examples here. So if I run this all correctly, did I do this? Yeah, it's a YAML help.
Is there any, not to derail too much, but any suggestions how we can avoid replicating this?
Your tooling. So like we have a dedicated team. So in the organization, we have a dedicated team to operate the Kubernetes. So they would have like, of course, repository to hold all this YAML. And then there would be like template. There would be template for you to actually start with instead of going through all this stuff. Yeah.
What I meant was, I think, for traffic server to YAML.
Oh, as you convert traffic server to YAML, and then?
We don't want to end up with this kind of YAML mess, really,
But I got the, yeah. No. I got what he said, because in the Kubernetes world, inside our own organization, the running joke is, your day-to-day life is just copy and paste. Yeah, because you just copy and paste your things from here and there, you make a few changes, and then you get your deployment. Right. Okay.
So when you do all these Kubernetes configuration files in YAML, how does that get translated into a Nginx configuration file for it actually?
That's where the Ingress Controller is supposed to do.
So what is it? Just a plugin
So-
for Nginx that goes ahead and makes the configuration?
Right. So I don't think it is a plugin in Nginx world. I think it's just a bunch of script that actually turn modify the
Yeah.
and then they would know how
So we
to.
just need something that is just
Yes, exactly.
configuration includes them.
Yeah. So if I'm going back to my things, actually, the fun thing is we actually have this. Someone in the community actually did this. So I researched for a long while. Someone actually created a Kubernetes ATS Ingress. And you guys know Felicity? Or? Yeah. So she did that. Yeah. Yeah. So unfortunately, I think she left this company or something for a year or something. So it doesn't work anymore. Yeah. But she left like basically the bare bone code, like and it probably works with an earlier version of Kubernetes as well too. So I'm not 100% sure the status of this particular project, but I'm saying that someone has attended that already. And then, so one of the things I actually want to ask the community is like, this sounds like something that we should actually be attending, right? If Nginx has one, if Envoy has one, if HA Proxy has one, why not we have another one as well too, right? Yes. Yeah, we're all busy.
Last event in that repo was July 2017.
2000 what?
17.
Oh, okay. That's a year or two, right? All right. Yeah. So, yes. So, the code, I actually read through the code. So the code essentially is to create a plugin. That's pretty much the same as what we were just doing.
And the advantage would be that you have content dependencies created by parent selection over each other,
Say that? No.
If you create a content dependency by using the parent selection, because you want to do it through parent selection, is that right?
Parent selection for.
I guess what I'm saying is, can you combine the ingress and the browsing ATS at that point then?
Yes, we can. Yeah. So yes.
Yeah, because then you use parent selection to create the content dependency, so you all have certain objects or certain caching on every cache and every
Yes.
object.
Yeah.
And that's the big advantage.
Yes. Right. Yeah. So we want to do that at the end of the things. Yeah. So one of the things I'm proposing is that we should be building our own Ingress controller And if you look at her solution is nothing more than turning this into a plugin. So the plugin actually inside that particular repository is making Kubernetes API call. Is also going to make a health check call to see how many of the pods is up and running, and then actually manage a hash table that the ATS will actually use the hash table to determine the destination of a particular routing rules for that. So all these are dynamically actually figuring it out for that. So, but unfortunately, that particular things, I was trying really hard to get it up and running, and it crashed in the latest version of the Kubernetes in some way. So I couldn't quite figure it out. But I think the idea is here that we want to do also be in the business of being able to provide an Ingress Controller for Kubernetes using ATS. Yeah, cool. So what other things I have? Yeah, so that's pretty much the things my team actually wants to do in the long run. And once it is actually everything is up and running, there's a whole lot of features in Kubernetes. And we were talking about Service Mesh and Envoy, right? And so in the long run, we want the Envoy and the Service Mesh to be between our service-to-service communication. So if you have a service inside the Kubernetes calling another service, Envoy can be sitting between them and providing like MTLS among them. It can do circuit break or whatever things this is. So, but ATS would be the one that is actually protecting all this infrastructure from the outside world. So traffic coming from outside the data center will hit our ATS first, and then our ATS will actually pass on the request to one of the servers here. And if the service is actually calling other service or fanning out and things like that, this will be all inside the Kubernetes framework, and using Envoy to actually doing service-to-service communications and getting all the stuff, all the goodies, things I want to do. Yeah. So that's the futures once we have Kubernetes for everything. And other things is on top of that, if you have a Kubernetes framework and all your web services are that, you can also do Knative, which is allowing you to do serverless programming and providing like your API using a serverless framework and doing all your implementations in a much different ways and a more flexible way of actually working on your APIs or your rendering logics, etc. So that's a lot of features that we have in our plans with Kubernetes.
And if you look at Ambassador as well?
Yes, Ambassador is actually trying to use Envoy in the role of how we are using our ATS for that. Yeah.
It's an interesting comparison because I've played Envoy to deal with Ambassador.
Right.
And how to manage it.
Yeah. Yeah. One of the things, of course, is like we have a huge team in ATS, which is Alan by himself. That's a huge team. Yeah. So then we have a lot of expertise in this thing. So we think that having the ATS to be playing the role for Envoy as in the Ambassador framework is advantageous for us because they will be able to actually make changes in terms of like various different implementations, changes for TLS 1.3 or stuff like that we basically get for free from them easily. So that's where we were having our thoughts on.
So are you guys going to do the Ingress part for ATS?
Yes, we intend to. Yes, yeah. But if you guys want to contribute or something like that, so if I'm doing that, should I be creating my own repository or should I put it in a subdirectory inside our repository tree or something? Okay, so I can just do that because, like, Nginx on HA proxy, right? What they did is like completely separate repository. One repository for the Ingress Controller. Yeah. Cool. But we should keep it the same first.
I think so.
it's a starting point. It is nothing more than the things that we can flip later on. Cool. That's all. All right. Any other questions?
So the argument for keeping HTML would be releasing or releasing the same technical ATS. You have that point. I don't know, that's like governance control or something.
Yeah.
If it's just a script or whatever like that.
No, it is actually a Docker file. So the let's look at what she did.
So she's actually running against Orbit traffic server 718.
Yeah, so the whole thing is driven off from the Docker file. So at the end of the whole CI/CD process for her is to actually put the Docker image into a repository that other people can use, and that's the deliverable. Yeah, and then this thing is like building. It's the plugin. Yeah, so she actually do pretty much the same thing. She have a watcher type of setup that is going to watch certain files, and there would be another thread that is actually calling the Kubernetes API, getting all the informations, and then based on that, she'll change that for that purpose. I think, yeah.
So are you thinking about resurrecting this work or what?
Say it again.
Are you thinking about like starting using this and fixing it, or?
Not too sure yet. I think this is too heavy. I think having it more like separated into, and these are all inside ATS.
Yeah.
So she's using ATS to actually make a async call to Kubernetes, get the result, massage the result. All these are inside ATS. I'm thinking it's better to be like on a separate process. Some script will be actually doing all these things and being run by daemon tools or something like that on a separate node. And then what ATS does is actually just have to watch out some files and then make the changes accordingly. Yeah.
This is ATS will keep getting to all of this, or?
No, it's all plugin.
Would you do it in like a non-hard programmable language? Like you know how to do it in C?
Exactly. That's what we were talking about. That she did everything in C, right? But I'm thinking that a simpler thing would be just like do much of the things through scripting, and only the plugin is actually done through C.
You're right, C++.
All right. Yeah. So she's lots of stuff. Yeah, I actually sent her a few emails, a couple emails, and she didn't reply. So I'm not sure, like whether. Okay. But if you guys can reach out to her, you can like pass this information along and then say, okay, we are interested.